Hi guys, my name is Kristian Quirapas. Once again, this is one of our episodes in Web3 Philippines Web3 Classroom. Shout out to the Read Write Own book behind my back on my board right there. In today's session, we are going to tackle a very great topic that's really close to my heart because this topic is something that I love and something that I live by every single day and I use for work exclusively every single day. All right. So today's topic is Russ intro coming from a senior blockchain engineer. So check it out. Yeah, let me show you my screen. Okay, so for anyone who's here, kindly comment down below Russ so I would know you guys are here and I'll be able to interact with you guys and share the knowledge and share insights in today's session. So it's gonna be quick. It's just 1 hour. Could possibly be 30 minutes if no questions asked. That's great. Give me a moment. Okay, so I see some people coming in. Now, today's topic is a Rust introduction for the outlearners. So it's not your typical Rust introduction where we teach programming languages as if they're regurgitated documentation. We're not going to teach Rust as a programming language by teaching you guys the syntax and syntax alone. Because the syntax you can learn and search online, you can learn and search from Google. So there's no need for anyone to teach you the syntax because you can learn it on your own. All right. So first things first, what's an outlearner? You might be asking, what is an Rust introduction class for the outlearner? Well, an outlearner is simply you learn what the average don't want to, so you can do what the exceptional can and more. And another way to think about it is an outlearner is someone who learns what he needs to learn in order to achieve the goals he set for himself. Because most people wouldn't do that. Most people wouldn't learn the hard things. Most people won't li- try to stay and work with the hard things because they're hard. So an outlearner bulldozes through that difficulty and learns it anyway because he understands why it's important to him and his goals. So, the general perspective I'm going to give you in today's session as an outlearner, you got to be wide in perspective. That means you got to know a lot of things, learn a lot of things, but be deep in one skill. All right. So when we say wide in perspective, a lot of people they wouldn't learn the horizontal skills that they need to learn to accelerate progress and grow in their respective industries and pursuits. But you will because you're an outlearner. So while people hesitate, especially with Rust, for example, a lot of people hesitate on learning Rust. They say, okay, Rust is hard, Rust is difficult, Rust is painful. But because you're an outlearner, you don't hesitate. Instead, in this moment, when a lot of people are running away and not learning Rust because it's hard, you jump in and conquer because you understand that it's important to you every single free time. So you learn every single free time. And today you will learn what? Rust. All right. So overall, to set the culture and the mindset of what we're pursuing here in this Web3 classroom session for Rust, do not outwork, instead outlearn. So what's Rust? Simple, Rust is a programming language. So as we all know, as developers, if you're here, Rust is a programming language that you can use to create different applications, different software, different systems. In general, computation, right? Fundamentally, a programming language is just computation. So you can do different computations with Rust. And interestingly, if you see Rust everywhere, you will see the emoji crab. Why? because Rust actually has a mascot called Ferris, who is conveniently a crab. So the community decided that the symbol of our community is the crab. So if you guys see someone, a developer who has a crab somewhere in his profile, he or she is probably a Rust engineer. All right. So Rust in general is coined as a systems programming language. When you say systems programming language, it's often a programming language that's used in low level systems, embedded systems, finance systems, critical mission critical systems like rocket or what do you call that? Self-driving cars, right? Firmware, those things. Rust is used for those. It's so systems programming language, but okay, I disagree. Rust is a language, so you can write whatever you want. You're the programmer, so it doesn't have to be just systems. It could be anything that you want. So before we go into the nitty gritty of what Rust is and what the programming language is and its constructs, let me introduce myself. My name is Kristian Quirapas, and I have 16 years of experience in tech, 11 years professionally, 4 years of Rust, and 4 years of Solana. So in today's session, I'll teach you some of the knowledge that I've learned from some of the companies I've learned from as well, like Grass, Apex, Stairdweb, Alchemy, Cusco, and Sonic. I've learned a lot of Rust things or blockchain engineering things in those companies and some of the projects I've worked with before as well. So to get started, the first thing we're going to learn about are those things that I call just read. Okay, so if you guys are there, I want to hear your comments. Comment down. Just read. Go. Shout out to Warb. Comment. Just read. Let's go. So we can start going over the Rust topics. Okay, so just read. Right? Today I'm going to teach you Hello World, variables and mutability in Rust, references, both access and mutability references, data types, functions, control flow, panics, and error handling. I will teach you all of that today. Are you ready? If you guys are ready, comment down below. Ready? That's right. I think for next session, it would be good to have this in a Discord server or something where I can hear you guys and see you guys faster. I think let's explore that eventually. But okay, I see you ready. The answer to that for this session is Google. Okay. For all of these things, how to do Rust Hello World, how to do variables and mutability in Rust, references, access and mutability, all these things, all you need to do to learn these is read. So we're not going to teach you that because that's something you can learn online. And if you can't, it's actually part of the training. You need to be someone who can. So Google. Instead, what we're going to talk about in the next section is those just code. When we say just code, it's those things that you need to actually build something. You need to learn Rust by doing for you to have an understanding of why that is or how things work that way. All right. So it's more of the experience-based knowledge that we're teaching today in this intro. I'm not going to teach you guys the documentation you can read online. That's not our goal here. Our goal here is to teach you experience-based knowledge as an introduction. So then when you start Rust, you have better understanding and better context coming in. So what are these things? All right. There are 4 things that I want to focus on in this introduction for experience-based concepts that you need to remember when you work with Rust. The first one is the mindset coming in. What mindset should you adopt when you are working or programming in Rust? Because You'll see later on that there are different mindsets or paradigms of thought when it comes to programming. But Rust has its own specific set of paradigms and thought models that allow you to be much more easier to program in Rust if you know them. So that's the first thing. The second thing I'm going to teach today is ownership and borrow rules, simply because ownership and borrow rules is one of the biggest barrier to entry for all beginners. It's a new concept. Specifically, it's just in Rust. And because of that, a lot of programmers trip in this part. But today you won't be, because I'll teach you. I'll show you what these are. And the third thing, wherein people trip and suffer, even if they're developers, is lifetimes and elision rules in Rust. So I'll be teaching you guys lifetimes, elision rules. We will be talking about that. But for lifetimes, it'll be our main focus. And lastly, where do you find information for Rust, for learning Rust? All right. So let's go over. Shout out to Jeffrey Lokban, who is sending a heart. Jeffrey Lokban, happy to see you here. Hope you learned something when it comes to Rust in this session. Okay. So mindset. The mindset that you need to adopt when you're learning Rust is something that I've learned when I was programming Rust for years now. Okay. So this isn't something that you adapt from the get-go, but it's something that I've learned when I was already deep into Rust. And for you to understand that, you first need to understand programming paradigms. So what are programming paradigms, right? Well, you can think of paradigms as just a way of thinking, right? Programming paradigms are simply just a way of thinking, a thought process in programming. And you guys are probably familiar with these. What are the common methods or style of programming that defines a set of principles, techniques, and patterns for structuring code to solve problems on a computer? What's a common pattern? Right? We hear object-oriented, functional, imperative, procedural, declarative, right? So these programming paradigms are thought processes that help you make decisions in terms of how you're going to structure your code. If you're object oriented, you think more in objects, in inheritance, OOP principles. If you're more functional, you see your program more in functions. If you're imperative, you're more on the step by step, or you're more on the clear flow. Procedural, if you're more on the procedures, and declarative if you're more on declaring or configuration. So these programming paradigms exist because it helps you make programming decisions based on these principles. So if it's object oriented, you would want to, let's say, create more objects in your code because it's object oriented. Okay? But the thing is, Rust is flexible. And tech is all about being pragmatic. When we say pragmatic, use what makes sense to you in your circumstance. That means you need to use what makes sense to your current circumstance internally and to your external circumstance. Okay? If you believe that using objects is the best way forward, use objects. If you believe that using functional programming paradigm is the way forward, then use that. However, here's the thing when it comes to Rust. Rust is flexible, but its inherent design leans towards some paradigms easier. So that means some paradigms are easier to adapt in Rust because its basic or fundamental design already works well with it. All right? So today, I'm not going to give you dogma. When we say dogma, I'm not going to give you set rules or absolutes. Rather, I'm going to give you experience-based thought principles or thought paradigms you can use so you can program better in Rust. So, in terms of programming paradigms, what is Rust? Once again, not dogma, no absolutes, but for me, in my experience, and I hope you see the benefits, it has been useful to think of Rust as a data oriented, procedural, and functional programming language. And we'll go over each one so you would understand why that is. The first one is it's data oriented. Rust Rust's design is so strict that it's best to get your data structures and the data that you need ahead as early as possible. Meaning, you need to ask yourself early as possible in your programming design or your software engineering journey, what data will I be using and what data looks like. For most of you, it will look like this. Okay, so let's zoom in on screen so I can show you guys clearer. It would look like this. You need to know, okay, what are the tables for my database? Or what are the data structures I'll use in my code? You need to know them ahead because once you set your data at the start in Rust, it's gonna be difficult to create changes because Rust is so strict. That means one change in your data will require a lot of changes and a lot of effort. Although it's strict because it wants you to avoid wrong data choices, wrong data usage, but to be to lean towards the easier side, plan your data ahead. So for me, it's easier to think of Rust in programming paradigms as a data-oriented language. Start from your data. All right. So what's the next programming paradigm or thought principle that I believe would help you? It's best to think of Rust as a procedural programming language. Focus on the step by step. Than trying to focus on everything at once. So Rust is verbose. So it's better to focus on, okay, what am I supposed to do here, here, here? Don't try to do everything at once because it's hard to track and difficult to read because Rust is so verbose because it's so strict. So it's better to think in procedures. Okay, I'm gonna do this first. I'll do this next. I'll do this next. So Rust, I believe, has been easy if you think of it as a procedural language. The next thing, okay, that I'll show you as an example for procedural is as much as possible avoid this. In the image or the diagram, you can see that a single function has multiple side effects before returning data. In code, you wouldn't really see that because it'll just be one function. These details are abstracted away. So instead, do this. Instead of trying to do side effect 1 and side effect 2, maybe it's just better to do side effect 1 first, return the data, do side effect 2 next, then return the data. A single procedure flow. Don't try to do everything at once. Take it step by step. Easier to think of. So this becomes more important when you start doing borrows, lifetimes, and polymorphism. These things you don't know yet, but these things you will learn are difficult if you don't think of your code as procedural. All right? So by thinking in procedural programming, it's easier to abide by the rules of Rust instead of forcing your way against the compiler, because the compiler in Rust will shout at you, which I'll show you guys later. And lastly, I do believe it's easier to think of Rust as data transformations or as a set of functions that transform data. And here's why. It's easier to think of Rust as a data-oriented, so you follow the flow of data. As a procedural, You take it step by step, and functional, that just simply, okay, I take this data, transform it, take this data, transform it, take this data, transform it. And this is so much easier later on once you get into Rust as a programming language. If you guys start building things with Rust, you start realizing, oh, it's so hard to do everything at once. In Rust, I must do it one by one. And for a reason, which I'll show you. Now we're done with mindset. The summary is think of Rust not as an absolute, okay? This is not an absolute advice, but a helper for you to have better thoughts around building with Rust. Think of it as a data-oriented language. Think of your data structures. Think of your data ahead. Start there. Think of the procedures, the step-by-step, and abstract away those complexities in data transformations, in functions. Through that, eventually it clicks and it makes it easy to program in Rust. So we're done with mindset. We're going to go to the nitty gritty where we call ownership and borrow rules. And we're going to include lifetimes and exclude elision rules. These are all jargons or Rust specific language. So it's okay. I'm going to teach this. If you don't understand this now, we're going to go over it. All right. For the elision rules, we're going to skip it because elision rules is hard to wrap your head around if you don't have full context yet. So we're going to cover that in a separate session, separate classroom, separate Rust introduction course so you guys get it better. Okay. So after that, we're going to go towards where to find this information and how to learn more. Okay. So going back, the first thing you need to understand when you're programming in Rust is what they call ownership and borrow rules. Okay. In Rust, there's this thing called ownership. When we say ownership, it simply means that in Rust, someone owns data. Okay. Someone owns the data. And this data needs to have only one owner at a time. Okay, because it's data. Data must be stored somewhere. Whoever has that data at his palm owns it. All right. So if I pass data to my right hand owns it. If I pass data to my left hand owns it. So there is ownership in data when it comes to Rust. All right. So the first two concepts, each value has an owner. Each data in Rust has to have an owner. And there can only be one owner in Rust. Okay? So there can be only one owner of data in Rust. Not at the same time. Unless, I'll show you later. But think of that. Only one owner. Okay? And lastly, when the owner goes out of scope, the value will be dropped. So when we say scope, think of it as if data is currently on my left hand and I cut my left hand off, of course the data is gone. Why? Because there's no more storage. Right? So think of it. This is your data. When it goes out of scope, no more data. Okay? And I'll show you that right now. In our example. So is the code clear? Please say clear if the code is clear. Yeah. Clear. Okay. Mizu is saying clear. Hi, Mizu. I think this is the first time I see you in one of our sessions. But hopefully you guys learned something. If you have questions regarding Rust and how to program in Rust, by experience, for beginners, for any level, please do ask in the bottom comments down below. Okay. So on ownership rules, This is the simplest example of ownership rules. Rust is block scope. When we say block scope, data is owned per blocks. Okay? Data is owned per blocks. So this braces in Rust syntax is a block. So think of it as a block. And old man is currently stored in this block. So old man is here in this block. Okay? He's here. What would happen to old man if I move him out of the block? And if, let's say, for example, we try to use old man outside of where he is owned and stored. Guess what? Rust will tell you. Cannot find value of old man in the scope. Why? Because the scope in which old man is stored into is already dead. Right? The moment he reaches this scope, this end of scope or end of block, old man is dead. So he can't be seen. Okay? But what if we put old man inside? Let's add some use to it. Okay? Oh. No errors because old man is within the same scope where it is stored. So I get access to it because I'm in the same block that has ownership of old man. But the moment I get out of this block scope, at the end of old man's life, okay, at the end of his scope, old man dies. And we can no longer listen to old man. He dead. He buried. Okay? He dropped dead. Because literally in Rust, we call this drop. At this point, old man, the memory holding old man, the space that is allotted to old man, the data that he holds is already dropped at this point. So if we try to get old man after he's dropped, bye-bye, nothing, okay? So that's the first thing, ownership rules. Data in Rust is owned in block scope, right? It is owned in block scope. Someone in Rust owns that data. That's why I think of Rust as a data-oriented language. Someone owns the data. And if you remove or you drop that storage, data is gone. Okay? So, what's next? Ownership. An ownership rules diagram. Remember this? Remember when I told you that you need to think of Rust as a data-oriented, procedural, and functional language because it's easier? Well, it's because that programming paradigm allows you to explicitly think of these borrow ownership rules by default, simply by thinking of the problems as data, steps, and data transformation. Naturally, these rules that Rust has will already happen because you think of things as data-oriented, as steps, and as data transformations. Okay? Let me open a diagram that I'll show you guys. I think it was closed there. I'll show you a diagram that will help visualize in terms of what I mean by this. So, okay, check this out. It's easier to think of it as a data-oriented, procedural, and functional programming language because You can see where data goes and how data looks easily. If you think of us as a data-oriented language, oh, so it's just me passing data to a function, passing it back, passing data to a function again, passing it back. It's also just me. Oh, it's just using functions to transform data. Oh, from black to red data to blue, blue data to green. Oh, it has to be procedural because it's step by step. Okay, it's not a shotgun where you do everything at once. It's one by one. So you you transform it with function one, you transform it again with function two, you transform it again with function three, and you see the ownership of data. You see that this data is now owned by function one and returned again to the main function. So main function owns it again. But you go into a function, so function two owns the data again. So it's easy to see the ownership rules simply by thinking of it as a data-oriented procedural and functional programming language. Once again, not absolute, it's just a way of helping you think. All right. Now, if there are ownership rules in Rust, there are what we call borrow rules. Okay? Because sometimes you want access to data without owning it. Okay? So think of this post-it that I'm holding right now. If I own it, I hold it. But the problem with that, let's zoom in on my video so they can see. So think of it as the ownership rules is like, okay, I own this data on my left hand, I own this data on my right hand. And the problem with that is that sometimes I want to read the data, but I'm far away. So I can't own it. Or I don't want to own it. How do you do that? You borrow. So borrow is just references in Rust. Okay, so we have what we call ownership and borrow rules in Rust. These are two most, like, the biggest hurdle for most programmers in Rust. At least two of the biggest hurdles, because there are more to come. As you level up, you're gonna see the learning curve. It's gonna be insane. So borrow rules is very simple. I summarized borrow rules into: you cannot borrow from a dead man, but you can do one of these. Either you tell him to stay alive longer, you copy the data nicely, or you clone it. And what do I mean by that? I'll show you right now. So I'll show you a simple example of the dead man. Okay, so there we go. Here. Ito. How do I wait? Let me just. I think. Okay, I'll do this just so we can center. There we go. So borrowing rules and lifetimes. I will show you how it works. Once again, data in Rust is owned in block scope. So Rust is owned, or this old man is accessible here in this scope because data is owned in block scope. So if I run this, all right, there should be no hitches. Okay, as you can see, successful because we're in the same scope. All right, as you can see, I'm borrowing old man in the same scope that he exists. Okay? Within the same scope that he is owned and alive, I'm borrowing him. So it's totally okay. So borrow rules say, since you're here, it's okay. But there's this phenomenon, or there's not phenomenon, but there's this error that often happens if you're not careful with your references. We call it dangling reference. A dangling reference happens when you reference data that is already dead or gone. So in this example, kid is referencing old man. So think of it as kid is talking to old man. Kid is talking to old man. He's getting wisdom from the old man. Let's take talking as a reference. Okay, talking is like a reference. So kid is talking to old man. So within the same scope that old man is owned and existing, kid listen. So kid listen to old man. Everything is good. No errors. But the moment we go beyond the old man's lifetime, okay? Because by the end of his scope, he's dead. The kid, once again, wants to talk to the old man. He wants to listen to the old man. But see, look what happens. It errors. Because what? Borrowed value does not long enough. In this error, you can see Russ tells you that old man died at line 59. Okay? So old man died at line 59. So who is kid listening to? His soul? Right? No one. So it makes sense. You're borrowing nothing because old man is dead. So going back to our rule, our simplified rule, you can't borrow from a dead man. Right? So you can tell him, old man, please give me your wisdom. He already dead, so you can talk to the old man. All right. So if if you're having troubles with borrow rules, just envision it as a kid talking to an old man. If an old man is dead, you can't talk to him. He's dead. But you can most definitely, number one, tell him to live longer. We're not going to cover this because it's complicated. We're going to cover this in a separate session. But telling the old man to live longer is what we call lifetimes in Rust. And 2 and 3 is if you can't talk to the old man, then maybe you can write down his wisdom. You can copy his wisdom. You can clone his wisdom. Okay, so here's old man. Let's do the kid. It was old man, that clone. Ay. Mutable. There's no deref 3. Yeah, so I need to implement that. But in general, what you can do in Rust is you can clone the data and this will be okay. It's not working now because I didn't implement the trait that is required for me to clone it in this example. And I want to get into traits because it gets complicated. I want you to focus on borrow rules and ownership rules for now. All right. So what my other example? All right. Going back, just remember this. If you encounter borrow rules in Rust, when you start programming in Rust, you can't borrow from a dead man, but you can always tell him to stay alive longer via lifetimes. You can copy or clone his data. Okay? Because if you can't talk to him, might as well record his wisdom, his language, his thoughts. Now, there are 2 more forms of references or borrow or types of borrows in Rust. It's called shared reference and exclusive reference. And I'll show you what these two things are by a demo. Okay. So a shared reference is a reference that can be shared. All right. That's why it's called shared. Me. Here, it's this one. Okay. Do you have two mains? Okay, good. So this is what we call a shared reference. You can see all three kids are listening to the old man. Okay, so all of them are listening to the old man, and there are no errors. So when we run this, this should work. Oh, everything's great. It works because a reference can be shared if it's not mutable. So when we say it's not mutable, you can't change the data. So it's okay if every single one of them listens to the old man because the change of the data doesn't change anyway. It's constant. But the problem arises when we have what we call exclusive reference. So when does a reference become exclusive? A reference become exclusive if one of the kids is what we call an exclusive reference is a reference wherein you can mutate data through that reference. So in this case, think of it as kid 1 is a shared reference. He just listens to the old man. Kid 2 is a shared reference. He listens to the old man. But kid 3 is an exclusive reference. He talks to the old man. And if you're talking to the old man, the other kids wouldn't be able to listen to him because you're busy talking to the old man. The old man is listening to you. And because the old man is listening to you, then what happens? You cannot, the other references can't listen to the old man because you're talking to him. Okay, so that's what exclusive reference is. If you see this syntax, mute, it's what we call exclusive reference because you can change data through this reference. And it's exclusive because it's not good to read from something you can write to at the same time. Because the problem is that how would you know that the data that you're reading is updated? And Rust ensures that it's updated and the data that you're reading is accurate by making it impossible to read and write with the same reference, with different references. So either you only read, either everyone listens or only one talks. Okay, so how do you change that? If kid 1, kid 2 are no longer listening, so let's say, for example, kid 1, okay, kid 1 and kid 2 are no longer listening, then there are no errors. You can talk to the old man because no one else is listening. So it's okay. It's okay to talk to the old man because no one else is listening. But the moment these kids or these shared references come back, it is impossible to have an exclusive reference. Okay? All right? So the only way for you to do that is to eliminate the exclusive reference and just make everybody share the reference. So it's okay to share the reference. No errors there. Right? So that's shared and exclusive reference. It's called, in most beginners, it's called mutable or immutable reference. But for this session, I want you guys to use shared and exclusive reference because it's much more in line with how we use it in the industry, in the community as well. We don't use immutable references. Instead, we use shared and exclusive because it's easier to understand. Okay? So for a subtype of borrows, you can either read all reads or single write. You can't read and write at the same time through references. You can only read for one or everybody reads the same. Okay? All right, so going back to our slide, we're done with the borrow rules. I know these are all very high level, very simple, but this will help you guys once you go in. You will get this once you start coding in Rust. It will make sense. Okay, which we'll do in other iterations of this session. Okay, so next topic we're going to cover is where do you find information regarding Rust? Where do you learn this? Okay, and the answer once again is you Google. Yeah, you Google. Because building the strategies, discipline, and grit in finding the answer for your questions in Rust specifically is also part of your training. So the things, the concepts that I've introduced to you are meant for you to ask questions in your mind. What are borrows? What's a functional language? What are data transformations? What are shared exclusive references? What are lifetimes? This session is designed for you to think and try to find the answers because it's part of the training. All right. So for this session, we just done an intro, very high level. We will go deeper, and we can only go deeper with examples and codes. We cannot go deeper unless we do it. We really code something, or you yourself really code something because it's gonna be confusing. So today, I hope you guys learned something about Rust and you've learned the keywords you will be researching tonight and the principles you need to think when you're coding in Rust. In summary, this session is all about thinking of Rust as a data-oriented, think of your data, procedural, think of how you're going to change that data in procedures, in step by step, and think of how you're going to transform those data in step by step. Okay, so data-oriented, procedural, and functional is how I think of Rust, and it makes it easy for me to design things in Rust. So if we're done with the session today, I'm we're hosting an exclusive private cohort wherein we will train you guys how to get into the industry as a professional blockchain engineer, and Rust is one of our key offerings. This is an exclusive and private cohort, a Telegram group. Join if you are interested in that session. If you are interested in this cohort, join this Telegram group and we'll keep you updated. So I open the floor is open for questions for the next 12 minutes before we close the meeting. So if you guys have questions, please comment down below in YouTube, and then we'll talk about Rust and the concepts that we have just talked about. Where are you guys currently? Are you on YouTube? Are you on Facebook? Okay. So if no more questions, thank you guys. Thank you guys once again. I am Kristian Quirapas. I am the co-founder and president of Web3 Philippines, a community which aims to teach developers how to be professional blockchain engineers so they can tap into the industry and see what they can own and what impact they can create in the blockchain industry globally. So we have more of these sessions. I'll be covering Rust more and doing more coding, more in-depth discussions around Rust. So I hope to look forward to you guys. See you soon. Bye.